Dear learners, this is the third in the series of our general physics experiment, where we are going to verify a very important law, that is none other than the Newton's third law of motion. Now, in order to verify that, we have taken an arrangement where we are using two spring balances. So, the first part of our objective is to understand the operation of a spring balance, that is how the extension of the spring in the spring balance is proportional to the weight which is hung. Number 2 is to make an arrangement with two spring balances in such a manner that the pull in one is experienced by the other. So, basically we are trying to create a situation where there would be action and reaction between two spring balances, as it happens in a game of tug of war between the two teams. And the third objective is to verify the third law of motion. The most crucial part of the apparatus are these two spring balances. We shall be using this to measure the action force, and this white spring balance to use the reaction force, and I will be calling this as the action spring balance and this as the reaction spring balance. Spring balance, as you may remember after observing the experiment on measurement of density, that the spring balance is hung from this support and then the weight is hung from this hook. So, the same thing will take place here, only thing they would be in horizontal posture and the pull will take place in horizontal manner. That does not matter. The thing to understand is that the extension of the spring is proportional to the weight, be it horizontal, be it vertical. Extension of the spring is proportional to the weight that is being hung, and since we would be measuring the force here, we will be measuring using the unit Newton, not kg. And these are the markings which measures the extension. So, same thing happens with this spring balance. Only thing is that rather than hanging the weight, it is experiencing the pull due to the reaction. So, now we have understood, or rather we have recalled the operation of the spring balance. The next important thing to do, as you do in case of all instruments, you measure the least count, that is the minimum extension, and in accordance with that the value of force which can be measured by the spring balances. Now, first the action spring balance. Now, here there are 5 marks between 2 Newton. So, each such mark is equal to 2 divided by 5, that is 0.4 Newton. So, 0.4 Newton is the least count of the action spring balance, whereas here you have 5 marks between 0 and 1. So, 5 marks is equivalent to 1 Newton. So, each mark is equal to 1 by 5 Newton, that is 0.2 Newton. So, 0.2 Newton is the least count of this spring balance. The third crucial thing is to know the zero error. So, now the weight which is hung here is 0. So, the reading should also be 0, but the reading is not 0, it is above 0. And you can make an estimate that it is almost 2 marks above 0. The least count was 0.2. So, 2 into 0.2 is 0.4 Newton. So, 0.4 Newton is the error, and this is a negative error because it is above 0. Effectively for 0 it is measuring minus 0.4 Newton. So, from the actual reading minus 0.4 Newton has to be subtracted. So, effectively it gets added to the reading. See, if the reading is 0.8 Newton, it should actually read 1.2 Newton. And for the action spring balance, here when the weight is 0, the reading is equal to 1 division. So, here the least count is 0.4 Newton. So, it is 1 into 0.4, it is 0.4 Newton positive error. So, this error has to be subtracted from the reading which we observe in this spring balance. So, if the reading is say 1.6 Newton, it should actually be 1.6 minus 0.4 equal to 1.2 Newton. Now, let us understand the apparatus and the experimental arrangement. Now, the base of the apparatus are two rectangular wooden blocks which have been connected here, and there are 4 essential parts. The first part is a block, the second and third parts are the 2 spring balance which are very vital to this experiment, and the fourth part is a pulley, and through the pulley we are hanging the weights down below. So, what we have done as a block, we have used again a makeshift arrangement. We have used a glass slab which is heavy enough to hold these items. It has been stuck with the wooden block with the help of a tape, so that it becomes quite stout. And then we have tied a string round it which is holding the first spring balance, and then this spring balance's hook is made to connect the top of the second spring balance, and the hook of the second spring balance goes over the pulley through this thread, and finally it goes to the hanger from where the weight are hung. So, now you can understand that the weight which is hung there is stretching through the pulley, and it is creating the stretch on this red spring balance, and this stretch gets transmitted to the white spring balance because it is fixed. And so, the action created by here is getting converted into reaction created on the second spring balance. So, we have been able to create an arrangement where action and reaction can be observed, and as you know that action and reaction act on different bodies. So, action acts on the red spring balance, reaction acts on the white spring balance, and we have to verify that these are equal. So, at this stage let us recall Newton's third law of motion. The statement is very simple, but you have to understand the inner significance. To every action there is an equal and opposite reaction. I repeat, to every action there is an equal and opposite reaction, and remember, action and reaction act on 2 different bodies. So, the first thing which you have to ensure that the action reaction situation created here conforms to that, that is, action acts on the red spring balance, reaction acts on the white spring balance. So, now we have set up the experiment, and we will take readings by changing the weight given in the hanger. We are now in a position to perform the experiment, and for that I will request my colleague Ms. Vijayalakshmi Pradhan to assist me in changing the weights. Now, as you can see, you have 4 disc type weights on a hanger. The hanger weighs 50 gram and each disc also weighs 50 gram. So, that is 50 plus 4 into 50, that is 50 plus 200. So, what is hung there is 250 grams. And then you have to read the force on the action spring balance and the force on the reaction spring balance. Now, the action spring balance is reading 2.4 Newton, but you remember this had a positive error of 0.4 Newton. So actual reading is 2 newtons, and the reaction spring balance is reading 1.6 Newton, and again you would remember that this had a negative error of 0.4 Newton. So the correct reading is again 2 newtons. So within the limitations of the apparatus, we have been able to establish that the action and reaction force is each equal to 2 newtons, which verifies Newton's third law of motion. Now we will perform this experiment with different weights. We have done it for 250 grams. We will reduce the weights in stages of 50 grams or 100 grams as it may be convenient, and then we will present the result in front of you. So the action and reaction force for different weights are being presented through the table which you can see on the screen. Thus, we have taken 5 observations for the action force and 5 observations for the reaction force, and we have noted them, which you can now see on your screen. Corresponding to the action force 2.4 Newton, which should actually read 2.0 because there was a positive error of 0.4 Newton. The reaction force is 1.6 Newton, but again here is a negative error of 0.4 Newton, which makes it 2.0. And likewise, the remaining 4 readings, as you can see, the action force is 2.2 Newton, which comes out to 1.8 Newton. Reaction is 1.4, which again turns out to be equal to 1.8 Newton. The action force is 2.0 Newton minus 0.4, that is 1.6 Newton. The reaction force is 1.2 Newton plus 0.4, that is 1.6 Newton. The action force is 1.8 Newton, that is 1.4 Newton. The reaction force is 1.0 Newton, that is 1.4 Newton. The action force is 1.6 Newton, which is 1.2 Newton, and the reaction force is 0.8 Newton, which is actually 1.2 Newton. So we have reasonably well been able to verify the third law of motion. Main source of this experiment is the readings of the spring balance, and which you should carefully observe and particularly take care of the least count and the zero error. And the other thing is that when the spring balances are moving on the wooden slab, there can be friction, and due to this friction there can be changes in the observation, but that would be too delicate to measure, but that still remains to be an important source of error. And also the motion of the string over the pulley should be frictionless as far as practicable, though a frictionless pulley cannot be realized in practice. Similarly, there can be friction between the stand of the hanger and the masses which are inserted there. So these are the possible sources of error of this experiment, a very vital experiment which verifies Newton's third law of motion. Thank you.
घर बैठे पाएं राष्ट्रीय मुक्त विद्यालय शिक्षा संस्थान यानी NIOS में एडमिशन, वो भी एकदम आसान तरीके से, जिससे शिक्षार्थियों को होगी समय और धन दोनों की बचत। NIOS से शिक्षा कभी भी कहीं भी। शिक्षार्थियों, क्या आप जानते हैं NIOS में एडमिशन लेने का सरल और सुगम तरीका, जिससे शिक्षार्थियों को ऑनलाइन प्रवेश लेने में सहूलियत मिलती है। NIOS में प्रवेश की प्रक्रिया पूर्णतया ऑनलाइन है। शिक्षार्थी घर बैठे इंटरनेट द्वारा प्रवेश के लिए सबसे पहले NIOS की वेबसाइट www.nios.ac.in पर लॉगिन करें। अपना ईमेल आईडी और पासवर्ड डालकर अपना पंजीकरण करें। पंजीकरण के बाद लॉगिन करने पर ऑनलाइन प्रवेश हेतु आवेदन पत्र खुलेगा। आवेदन पत्र को निर्देशानुसार भरें और प्रिंट आउट लें। इस प्रिंट आउट पर अपनी फोटो संलग्न करें। ऑनलाइन प्रवेश के लिए शुल्क हेतु भुगतान के तरीके हैं: क्रेडिट कार्ड के द्वारा, डेबिट कार्ड के द्वारा, राष्ट्रीयकृत बैंक के ड्राफ्ट के माध्यम से, जो कि सचिव NIOS नई दिल्ली या नोएडा के पक्ष में देय हो। भरे हुए आवेदन पत्र के साथ साथ डिमांड ड्राफ्ट और संलग्न किए जाने वाले दस्तावेज हैं: जन्म रजिस्ट्रार के जिला कार्यालय से जारी जन्म प्रमाण पत्र की सत्यापित प्रति, जिसमें जन्म तिथि अंकित हो, पिछले विद्यालय से प्राप्त विद्यालय छोड़ने का प्रमाण पत्र, जिसमें आवेदक की जन्म तिथि लिखी हो। प्रवेश फॉर्म का प्रिंट आउट NIOS के संबद्ध क्षेत्रीय केंद्रों पर 10 दिनों में पहुंच जाना चाहिए, अन्यथा उचित दस्तावेज न लगे होने पर आवेदन फॉर्म रद्द किया जा सकता है। प्रवेश प्रक्रिया की पुष्टि होने के बाद शिक्षार्थियों को परिचय पत्र व अध्ययन सामग्री डाक द्वारा तुरंत पहुंचाई जाती है। ऑनलाइन प्रवेश एक बहुत ही सुगम और सुविधाजनक प्रवेश प्रणाली है। ऑनलाइन ऑन टाइम फॉर सेफ एंड सिक्योर एडमिशन।
Dear learners, we are going to perform an experiment to estimate the pressure exerted by a heavy block when it is kept on a soft bed. The objective of this experiment is to understand that pressure is equal to force per unit area. The second objective is to place that block on different sides so that you can change the area while the weight remains the same. And the third is to determine pressure exerted on the three surfaces using the formula force per unit area. Now, one of the ideas behind this experiment is to sensitize you how to perform such an experiment with throwaway pieces. Now, here we could collect two bricks, and the bricks were not of even shape, the edges were not sharp. So, what we did, we placed the brick one after another, and then in order to make it presentable, we had wrapped it up with papers. First we wrapped it up with a white paper, and then to indicate the 6 surfaces, or for that matter to differentiate between the 6 surfaces, we have pasted papers of different colors, like green color on the largest surface area, yellow color on the second largest, that is this and this, and red color on the smallest surface area, that is this and this. And you can very well make out that the edges are not sharp. So, I will make reference to that when I talk about measurement of area. The other thing which we are using as soft bed, now something else has been referred to in your book. We are using again throwaway pieces. Several devices had come packed in boxes, and while packing they had used sponges, sponge blocks. So, we have used 2 sponge blocks one after the other, and we are taking the advantage of the rectangular edges, which you will see when we measure the depression of the sponge blocks by application of pressure. Now, coming to the determination of area. Now, ideally this should be a rectangular parallelepiped, which it is not. So, in order to measure the length, we have measured the length 4 times, that is this length, which again should ideally be same, but we have measured both of them, as well as this length and the length below. Similarly, for every surfaces we have measured the lengths 4 times, and then we have taken the weight of this block. you are supposed to take the weight with the help of a spring balance. We are not using the concept of spring balance here. We have already measured it because you have learned the use of spring balance in the experiment of determination of density of the material of a substance, and so you have learnt about spring balance there itself. So, for the sake of simplicity, we have already taken the weight of this block. Now, coming to the measurement of length, breadth and height. The four measurements of length are 23 centimeter, 21.8 centimeter, 22.5 centimeter and again 22.5 centimeter. The average is 22.45. The measurement of breadths are 13, 13.2, 13.8 and 13.6, average being 13.4. The measurement of heights are 11.5, 11.3, 11.1 and 10.8, average being 11.18 centimeter. Coming to the measurement of area, so we have to measure length into breadth, length into height and breadth into height. Length into breadth turns out to be equal to 300.83 centimeter square, that is 0.030 meter square. Length into height comes out to be 250.99 centimeter square, that is 0.025 meter square, and breadth into height comes out to be 158.12 centimeter square, that is 0.016 meter square. Now, as I told you, we have already taken the measurement of the weight, which has come out to be 5.275 kilogram, and that multiplied by acceleration due to gravity, that is 9.8 meters per second square, gives you the weight, that is the force acting downward. Now, the force acting downward is same whether you hold the brick in this position, whether you hold it in this position or whether you hold it in this position. So, the weight is equal to mass into acceleration due to gravity, that is 5.275 kg into 9.8 meters per second square, which turns out to be 51.695 Newton. And then we will have to divide it by the three areas. Now, when we divide it by the largest area, the pressure comes out to be 1723.2 Newton per meter square. The second largest, it comes out to be 2068.8 Newton per meter square, and the smallest 3230.9 Newton per meter square. So, as anticipated, pressure is equal to force per unit area. Force is same in all cases, but the denominator changes. When the denominator is maximum, the pressure is minimum, as has happened in the first case, then in the second case, and then it is largest when the area is smallest. So, now we will do the exercise of placing the brick on the sponge, and we expect that in the first case the depression will be smallest, in the second case more than that, and in the third case it will be maximum. So, what we have observed in this experiment? Well, the difficult part was to observe the three cases of depression, and that is why we have used graph paper, because in the graph paper the millimeter marks are very accurate. You have to make an eye estimation by using the pencil point to locate the position of the sponge head, and we found that in the case of the maximum surface area it is smallest, then larger than that, and in the third case it was maximum, which establishes that pressure is equal to force per unit area. You would recall that the source of error is again to align the sponge head with the marks on the graph paper, but if you can do your eye estimation reasonably well, then you get a genuinely good result. Pressure is equal to force per unit area, and so measurement of area is very crucial, and for measurement of area, measurement of length, breadth and height are also very crucial, because the three areas would be length into breadth, length into height and breadth into height. And we have taken the measurement of length by placing it on the millimeter graph paper, which is reasonably accurate, the least count being equal to 1 millimeter. So, here we are using two sponge blocks one over the another to prepare the soft bed, and we will place the brick on the soft bed. Now let us see where the top level of the sponge block lies, and we shall read this from the graph paper. We start from the bottom, 1 centimeter, 2 centimeter, 3 centimeter, 4, 5, 6, 7, 8, 9, and it is at 9.4. So the top level of the sponge block is at 9.4 centimeter. So 9.4 centimeter is a reading corresponding to the neutral position. So now we have placed the brick on the sponge, and we will estimate the depression of the sponge, and we have placed it on the largest surface, that is a green surface, you will remember, and then subsequently we will place on the yellow surface as well as on the red surface. And after placing it, now we will look at the position of the top of the sponge. It comes exactly here, so let us try to read it. 1, 2, 3, 4, 5, 6, 7, 8, and another 3 millimeter after that, another 4 millimeter, so that is 8.4 centimeter. So originally it was 9.4 centimeter and now it is 8.4 centimeter, so the depression is 1 centimeter. So now we have again placed the brick, but this time on the yellow surface. You will remember the surface area of the yellow surface is second largest, and it is resting on that. Now let us see how much it has got depressed. The pointer is here, so I will read this mark 1, 2, 3, 4, 5, 6, 7, and it is almost equal to 8. It is almost equal to 8. So the depression is now equal to 1.4 centimeter. Now we have placed the red surface, and this being the smallest surface, we expect the depression to be maximum. Now let us see what has happened. This is the line of the sponge head, and again if we follow the mark, it comes roughly over here, that is this mark, and this mark if we count, this is 1, 2, 3, 4, 5, 6, 6.5. So 6.5 means the depression is 9.4 minus 6.5, that is 2.9 centimeter. So as expected, the depression is maximum when you have the smallest area. Thank you.
हिंदुस्तान के हर कोने में नौजवानों के पास प्रतिभा है, उन्हें अवसर चाहिए।
NIOS देता रहा है युवाओं को अवसर आगे बढ़ने का। NIOS से पढ़ने वाले इन युवाओं ने किया है संस्थान को गौरवान्वित। दिव्यांगों ने बन के दिखाया है सबल और आत्मनिर्भर। NIOS के साथ आप भी जुड़िए NIOS के संग।